Greetings from Data Gaps. In this short overview, we would like to showcase how Data Gaps DataOps Suite can provide a solution that's not only comprehensive, but also a great return on investment and overall boost to quality of your data pipelines. Firstly, a quick refresher on why data quality matters. Multiple studies have shown how data quality directly impacts more than 26% of a firm's revenue. This isn't a shocking number when considering that most data incidents take about 9 hours to resolve, which inherently takes up about 40% of a data engineer's workday. With 10 years of experience in the field across multiple sectors, including banking, healthcare, logistics, and education, we at Data Gaps have solved these problem statements numerous times. We have multiple success stories under our belt for data quality monitoring, migration validation, transformation validation, and of course, BI validation. A common quote for our success story is post-implementation of Data Gap's automated solutions, our clients' data engineers are free to focus on the actual problem statements as opposed to the data quality issues and restarting pipelines. Now that we have set the stage, we can define the points of the pipeline where data validation and governance are crucial. We will use the standard ETL pipeline as reference for the base architecture. This includes ingestion of data from various vendors and sources in different formats, collecting this data into a landing zone before curating it and preparing it with transformation tools, pushing the datasets into a production warehouse before segregating the datasets into data marts, and finally, the views and tables from production are used in BI tools and analytics for creation of reports and, of course, driving business decisions. With multiple layers, schemas, and databases in sequence alongside transformations and migrations to push the datasets from a raw state to a finally fully processed view, we have identified 6 major chunks where validation is paramount. We start with validation at ingestion. While the application has the capability to connect with the vendor directly to validate and score the data in terms of quality before it's even pulled into the system, this function can be performed at any state. Volume checks, null checks, domain checks, parent-child relationships, foreign key checks, duplicity checks, and many more user-defined rules with a zero-code deployment system and parameterized and exportable templates for easy management can be deployed and maintained to the suite easily. We apply shift-left philosophy to ensure we catch errors or discrepancies as early as possible, as rectifying these requires the least amount of resources and time. Secondly, we perform migration validation. A side note, we have a complete set of automation tools for validation of cloud or on-prem migration systems. A success story of ours involves on-prem SQL Server being migrated to the cloud version of Snowflake, where Data Gap's automation system helped the client with the validation of datasets, transformation and its logic, as well as BI reporting. In the current example, however, we use migration validation to perform a full data compare and profile compare of the files at the vendors against the received datasets in the landing zone. The application isolates mismatches, missing records, metadata discrepancies, rounding errors, allows reconciliation of logic, and much more. The application ensures the data sets between two platforms, and any two platforms for that matter, be it a file against a database another against another database, or an API against a BI report, or any combination of the sources that we see and that we will showcase in the demo shortly, can be compared directly. The suite provides an automated wizard to map datasets of any format against the other with automatic mapping, data type conversion, metadata conversion, thresholding, amongst a few features. The end user does not have to spend any time manually setting this up nor managing them overtly, and thus makes it very easy to have changes or additions into the system and makes validation a breeze. Next, we have data rules. Data rules play an important role throughout validating data in motion within a pipeline. The suite provides the users with a zero code or a no code system to define, parameterize, and run rules on multiple dimensions such as unicity, duplicity, completeness, validity, and more. The rules are also used to define business requirements and attribute validation. These rules are easily transferred between test cases and models. The application also provides a wizard to automate the deployment of data rules to hundreds of datasets at once. Next, ETL and logic validation. To ensure that the transformations and aggregations are accurate and to make sure that they do not leave unforeseen repercussions with consequent datasets and layers, we can apply white box and black box testing for transformations with replications of SQL, Python, VBScript, and Scala code. Or we can use user-defined rules on the transformations or datasets directly. While preparing data from landing to curated, ensure that each transformation is giving the expected results by validating them either against the rules or the transformed datasets. With an AI assistant to help create these queries in code, the developer can easily offload the task of validating the transformation itself. Data observability is the next stage. Note that this tool can be applied as early as the ingestion layer. Here we apply a complete set of validations of the data before pushing it to reporting and analytics. This involves user-defined rules across all datasets, profiling the datasets and reports, and machine learning-based anomaly detection. Everything ranging from pattern alterations, volume shifts, distribution shifts, percentages of nulls, and much more is noted. And any anomalies found are notified to the end user. The suite ensures that the data leaving your system, be it in the form of files, views, or reports, gets validated against business rules, past profiles, and expected patterns. Finally, we have BI validation. This could be considered one of the most important aspects of any pipeline, as here the data is used to drive business decisions. It is crucial that the reports remain trustworthy through upgrades, deployments, and migrations. To achieve this, the application deploys automated tools for upgrade testing, regression testing, report to data testing, report to report testing, performance testing, security testing, and stress testing for multiple BI tools. To round out, each aspect of the test cases comes with automatic report generation, scheduling, notification systems, integration with test plans, CI/CD tools, and of course, plugin support. Before we move on to the practical demonstration of the product and in the live demo, I'd like to spend a few minutes understanding the architecture. The first and foremost question, of course, being where exactly is the data going to be hosted and the application going to be hosted? Well, I'm happy to report that in most cases, our clients opt to install the application directly onto their infrastructure, and the product supports that. We do offer a bit of SaaS where we can host the product for you, but we understand that for most cases, data compliance and guidelines requires the product and the data to not leave the client's firewalls. And to this end, all components of the architecture, here you see three, all three will be installed directly onto your infrastructure behind your firewalls itself. With that out of the way, let's take a look and understand the three components in a bit more detail. Firstly, we have the Apache Tomcat server that orchestrates all the needed services. This includes your admin services, security services, reporting, and of course, connecting to the application and connecting to the end user as well. The second aspect is the engine. Now, this is the heart of the application as a whole, and we provide it in two particular slices. Firstly, we have an Apache Spark engine, which is built for ETL systems and primarily for high throughput, high volume requirements. This is based on a Spark session as it runs within one and can easily scale up on Kubernetes enabled clusters or can even work on a standalone on-premise cluster as well. All it needs at the end of the day is a Spark session. Once again, it's built for specific test cases where high volume and high throughput and multiple types of locations and sources and vendors are present. But to counter this, for ELT systems and for low throughput systems where more efficient solutions are needed, we have a database engine. In direct contrast with the Spark engine, the database engine runs within the corresponding database itself and uses the database's functions and temporary views to achieve all the data quality validation checkmarks that it has to achieve. An easy example for database engine usage is assuming you have an ELT system with all or at least most of the tables and views within the base Snowflake system itself. Now we understand that the task of even pulling tables or views out of Snowflake could be expensive in certain scenarios. So in this case, we would ask our users to use the database engine, which actually does not require the test cases or the data sets to be pulled out of Snowflake. The test cases can be directly run on the Snowflake engine itself. And thus database engine is pretty efficient usage in this particular fashion. Of course, it works very well for low throughput systems and is not as easily scalable as a Spark session would be. But once again, you don't have to choose either or for your system. You can choose one of the engines for specific use cases as well. Finally, the repository, which is by default PostgreSQL, but has Git integration built into the product. And this is where your base code of the application lies. This is where the test cases reside, and of course, the sample records and other tidbits of the product that you'll see. As a roundabout, we would like to iterate that the application can be installed directly onto your infrastructure itself. This is actually the norm for most of our clients. We understand that data compliance and guidelines imply that data never leave your system and your firewalls. And thus, our application has been molded to be directly agnostic of the cloud or on-prem nature of your system, and it can be installed directly onto your infrastructure, irrespective of what type of infrastructure that you're working with. For more details, you can of course have a better discussion on the exact deployment of the product as a whole. To round out, we do want to also define how exactly we can connect to the application. What we're going to showcase, of course, is the web browser version with the fancy UIs that is much more beginner friendly and user intuitive. But everything within the application is created with the developer first attitude, implying that everything, every feature that you see, be it creation of test cases, changing parameters, running pipelines, creation of reports, creating integrations, and every other aspect that you see can be done via REST API commands as well as CLI commands. This adds the added aspect of easy integration within the product, as we will see in the demo as well, but ensures that if you want to do something in an automated fashion, or if you would like to do something from your developer console itself, you can do that easily using the product. With that, we wrap the architecture of the system. Now let's have a showcase of the live demo of the product. In this demo, we'll be showcasing the ETL validator and data quality monitor primarily. So first and foremost, welcome to DataOps Suite. What you see is the home page. For starters, we have the common tasks, a dashboard to view the past and current pipelines and test cases, and of course, the user log activity for your personal logs as well as the team's logs. The most important aspect here is the container. The container is our multi-tenant isolation system built to isolate projects or environments. Basically, it's there to ensure that if you want to segregate your projects based on roles, guidelines, or associations or permissions, you can do that by making sure that the admin provides the correct access roles to the correct users and then assign them to the appropriate containers. In this case, we have a bunch of curated demos that we've created specifically for this use case, and those are in the webinar container. So I'll be using that. Before anything else, let's get started with the first aspect, which is how do we connect to the various sources? Well, as you see, the application has a plethora of sources that it can connect to inherently. All of these sources are available to the user by default. These include a good amount of JDBC connections that you can define, flat files or complex files, be it on on-prem or cloud location, API connections for those pesky connections which do not really have a JDBC system involved and you would still like to pull datasets from them. You can of course use an API connection, and of course a BI connection. This is especially helpful when pulling reports and the datasets from the corresponding reports from Tableau and Power BI. Let's take a look on how exactly these connections are made. At the end of the day, a JDBC connection is a very simple connection that needs the credentials and the URL. This is the only thing for this for the suite as well. The application does come with an internal password vault out of the box, but can easily integrate and connect with your existing credential management services as well. In a similar vein, let's check out how do we connect to flat files or complex files. So here we'll pick up a CSV file and we'll assume that the CSV file is placed on S3. In this case, all we need is the corresponding credential and the path. In this case, it's the access keys and the secret access keys, and the bucket name is the path along with the location. In the same way, if you're working with, say, a complex file, assuming you're working with an XML file, all you have to do is define where this is kept. In this case, we can also define, let's go with an ADLS for now. And it's in a similar vein, all you have to do is define the container, the storage account, and the access keys, and you're good to go. Moving on the connections, if you want to define an API connection, while the application does provide a good number of defined authentications methods, you can also define your very own using plugins or code systems. You can also add a lot more options as seen in the screen. Finally, the connection to Power BI is pretty straightforward. Let's use Power BI as an example for BI tools. In this case, you have to define what type of application you'd like to work with. In this case, Power BI works with master users and service principals and the corresponding credentials and application ID. An application ID is basically an ID that Power BI can give to authenticate a third-party usage of the application. It's pretty straightforward to get, and we have a lot of documentation around the same as well. And the same lies for Tableau, where if you want to define a Tableau connection, all you need are corresponding steps. And if you want some additional SSO certifications or SSO validations to take place automatically as well, there are templates for web login commands that you can take from the support team itself. At the end of the day, it's a breeze for any end user to define a connection to the suite. Now that we've wrapped up the sources, let's get into the actual meat of the product, which is making sure that your migrations are being validated and your transformations are being validated, and of course, applying some observability on top of it as well. We're going to start with a very basic example, which has the following business statement. Here, the problem statement that we're going to work with is that you have a SQL server, which could be on-prem, which could be on cloud as well, and the corresponding data sets within this on-prem server are being migrated to Snowflake. This could be a one-time migration, this could be a daily process. Either way, the main problem statement here is that we need to make sure that the migration has been done successfully. As you might imagine, a basic migration such as this might hold a lot of problems, be it through the method of transfer, as in if you're transferring files using CSV or other aspects, or through the batch transfer method of the application itself. And of course, the main culprit here being that SQL Server and Snowflake inherently have different architectures and thus can infer schemas around integers or just have auto trimming settings differently present within the system. And this is of course presided with the aspect that metadata is obviously very different in SQL Server as well as Snowflake. So of course, this is something that we all understand, and that's why we have to define a migration validation system. But let's see how the product does it. Of course, here's what you see is just 3 nodes, but let's take a deeper look on what nodes can we use. The application can provide all the sources that we saw earlier. You can define as many sources as you would like in a specific test case. And within these data sets that are pulled in, you can apply any type of processing. This could be SQL processing, this could be Python, Scala, applying some DB scripts on top of them, or using plugins on top of them as well. So you can pick up data sets from any specific source and apply any specific processing on top of it. Ignoring data quality for a while, you see that we can also push them back into sync, where we can actually save them as targets, either as files or as views or tables, which can be replaced or appended to existing views or tables as well. So if you see this particular process with the source, the processor, and the sink, you will be surprised that yes, there's a full-fledged ETL tool. And that's because if you want to validate an ETL system, you would have to replicate an ETL system and have it as your backbone. So a few of our clients do in fact use our tool as a full-fledged ETL tool, and so can you. Going for the meat of the product is actually the data quality nodes. Here's where we actually start with data compare, but we'll be focusing on the few other nodes as well as they come across. Note that from this particular view, you can understand that the end user is free to define their very own test cases. The suite does not define any limitations on the user on the usage of the product, or define any pseudo limitations on the product as well. If you think you would like to transform certain data sets before validating them, you can do that. Correspondingly, if you want to run a validation against a report and a raw API output, you can do that as well. We provide the tools to the end user, and we hope the end user has benefited from the saving in times and the comprehensive nature of the product itself. Now let's get back to the actual use case. We dragged and drop a JDBC connection. We defined that our source is a SQL server as here. Then I used a query builder to actually define this particular query. I can parameterize this, associate parts and whatnot. In this case, I just dragged and dropped this particular query from my metadata, and this is my DIM customer. The results of this, as we see, are about 18K records being built up, and we have a preview of the sample records as well as the schema and the throughput. Note that this session is not live. Every time we run the corresponding node, the previous session has been loaded up as form of the result of the past run. So here, this is what we see in the previous run. Of course, we can rerun this and of course view the previous run in run history as well, as I'll showcase towards the end of the demo. In the same vein, I've also picked up the same table, but from Snowflake. In this case, as you see the properties, so I have Snowflake within my system, and you'll notice that the column names are slightly different within my system. Now, this is something that you might see, that there might be slight alterations within the column names, and this is something that you might be worried that, hey, I might have to go in and manually map this. Well, the application has got you covered. To move into the third node, this is where we actually start to work. Now that we have loaded our data sets from Snowflake and SQL Server, we first load in a data compare node. What this does is it ensures that at the end user can automatically enable data type conversions. This is, of course, if you're working with, say, decimals and integers at both locations, and you would like to validate the actual data. Easy example here being that in SQL Server, you are working with 3.0, but in Snowflake, you either have 3 or you have 3.000. So strictly from a computer vision perspective, these two are slightly different because the data types itself are different. But if you would like to ignore that and match the raw values, you can do that as well. In a similar vein, you can also ignore case sensitivity. And of course, if you're working with flat files, considering null and empty spaces the same is pretty crucial, as null, the concept of null does not really exist in CSV files. Moving to the next aspect, we see mappings coming to picture. As said earlier, this is something that the application takes care of automatically. This mapping was not done by me. This was done by the application inherently. And as you see, it has mapped about 25 columns. Some columns have been left unmapped. It's because the application could not find a corresponding column in the dataset B for this. Of course, I can manually go in and define if I want to define a specific column for this, but I've chosen to leave this out for the sake of the example. If you're working with a mapping file itself that holds columns of datasets A and B, you can upload that directly, be it in JSON or CSV file. And of course, you can manually define these as well. You can go in and change the data type if you want to from this corresponding system itself. So before you actually validate this, and if you don't want to use the automatic data type conversion, you can do this manually as well. Custom expression is present. So if you are not happy with just the casting functions that the product provides out of the box, you can actually define case when statements in this particular custom expression as well. And of course, if you're working with decimal values and float values, rounding errors are something that are expected. And if you want to define thresholds for test cases to be deemed as positive or negative, you can do that using defining upper and lower bounds for your threshold systems. Now that we have done and defined this mapping automatically, let's look at the results. In our results, we see that we have a 99% match. So yes, a good amount, at least nearly all records that were transformed from SQL Server are matching with the records in Snowflake, with only 4 records being mismatched. And we can see those mismatched records here. But of course, just looking at this mismatched records is not enough. Maybe I want to send this out as a report. Maybe I want to reconcile this particular data set, or maybe I want to raise a Jira ticket for this. So the application comes with usages of all of these specific use cases in a plethora of ways. Of course, if you like to work with this particular set of mismatched records, either you can download it directly from here, or if you want to say reconcile this, I'll drag and drop a SQL node, as you see, and then I'll drag and drop data compare difference. This particular data set is the data set that we were looking at earlier within mismatched records. So now I can use it for further processing or reconciliation as well. The application also has inherent plugins that the user can define. So we just add a plugin right there. Let me find a Jira ticket plugin. There we go. So this plugin will automatically raise a Jira ticket if it finds the corresponding difference in a particular data set. But of course, this is not the end. If we go back, we see that in SQL Server, there are a few records present only in SQL Server. And this is an essential and crucial catch for us. Because as you might imagine, sometimes transfers and batch processes might fail intermittently. So in this particular use case, we find that, okay, from our SQL Server, a batch or a few set of batches or files were not transferred properly, thus indicating that from SQL Server, a few records are missing. And this is something that needs to be critically caught, especially when working with migrating datasets. And of course, this is also its own dataset that you can work with for reconciliation or further processing. Just to showcase the other aspects, column-wise mismatches showcases the mismatches at the primary key level. And if you're working with duplicates, those will be popped up here as well. So that is the base component of data compare and how exactly it works. Before I move on to the next example of data rules and other aspects, what I would like to do is quickly illustrate how this can be done using a system of wizards. I want to showcase this wizards because it's just one of the wizards that the application comes with. You can actually define multiple wizards within your system as well. So here I will pick up a different container that I've built for this. I'll get into data flows, and here I'm going to generate brand new data flows or test cases at once. So here I give a prefix, I define the environment I'm working with, and here the use case is that I'm migrating datasets from SQL Server to Snowflake. I'll import the tables automatically, and here I see all the metadata present. I'm going to work only with dimensional tables. So I'll filter them for just dimensional tables and drag and drop the data sets I want to work with. So here you see that the data sets from my source are automatically being found for their counterparts in their target, implying that if there's dim account present here for the corresponding schema and data sets and data types it holds, the target object is also being found. If in case this particular data set is not found, as you see with dim promotion, the user is prompted to define what exact data set you would like to work with. Once again, this has an associated file as well that you can directly upload. Moving on, the mapping, as you see, has been done in real time according to the datasets I was working with. There are 0 mappings which are unsuccessful. If they were unsuccessful, the user would be prompted to either find such specific columns and work with them, or work, and this as you see right there, or ignore them as well. So you can choose which columns you would like to run comparisons against. Next, we can choose the same options that we saw earlier, except this is for bulk. And then finally, I can create the test cases as we saw. So if I go to preview test cases, now you'll see the exact test case that we saw. Of course, I can go in and further change this, alter this if I have to, and add more specifications if I need to, or I can create a pipeline where I can choose to run all these test cases together at once. So in this case, as you might see, if I want to create a specific test case and run it all at once, all I have to do is add a data flow and choose which set of data flows I would like to add, either in sequence or in parallel. So in this case, I can group my multiple test cases together, be it in any particular form, and define a set of rules or conditional processing against them. So here I'm just running them. So these are my specific test cases that I created right now, and I've chosen to run them all together. So this is one of my pipelines. As you see, the application does come with inherent notification systems. The application also has schedulers inbuilt to the product, but it very easily works with your existing test plans, be it test plans with regards to Azure test plans, AWS test plans, or other such integration systems like CI/CD tools with regards to Jenkins or Git or other such places as well. Of course, Git works with the integration of the code, but if you have other ways to trigger these pipelines, you can use those as well. Now that we've quickly wrapped up our system with regards to the creation of data compares, let's move on to the other use cases. The next use case will be how exactly do we validate our test cases? So how exactly do we validate our transformations? So there are two basic trains of thought here. There's white box testing and there's black box testing. So white box testing principles involve the end user defining a certain transformation, and the QA tester now has to validate that transformation by replicating the logic of the transformation. In base words, if the end user has actually done the data set, in this example, we can take that geography key was the column which was affected, and this is the data set that has already been updated. Here, the development change has been done. You as a QA tester need to pick up the source file. This is where you pick up the raw source file, and you apply the logic, but you do not copy the code, as testing always has to be independent. You apply the logic from scratch here. Here I've defined him as a parameter of custom functions. I can use my OpenAI assistant to help me with this as well. And once I've done this, I can actually compare them once again. And here I see in the comparison, most of them are a pure match, and the mismatches are all limited to geography key, which is expected. And in this case, we see that there's a set pattern here between 18 and 20. And what this reflects is that the logic for 18 versus 20 is something that has not been coded correctly, either by me, the QA tester, or developer. Or it could also be a mapping error between the two environments. So one way or the other, I've isolated and found out a specific potential issue in the logic transformation of this particular use case. Moving on, we understand that this is not something that every specific that can be done for every specific transformation, as replication takes its own time. So in this case, we can do black box testing as well. Black box testing here, as the name suggests, implies that you as a QA tester, you're not entirely aware of the exact transformation logic here. So here I've defined transformation logic as just a parameter, but you're aware of the outbound limits that are needed on this transformation. An easy example here would be if you're working with multiple tables, you do know that at the end of the day, the particular transform data set should not have duplicates on certain columns, or its particular metrics should not be out of range or out of bounds for a particular set of limits. It could also be along other lines. It could be with regards to business rules. For here, we actually bring in data quality rules. A source data set is brought in and the columns are defined as is, and then you are given a zero code or low code system where you can actually just define what type of rule you would like to deploy. I'll use a duplicate rule for the easiest showcase, where I define the duplicacy rule, define alongside which columns I want to define my duplicates, and that's it. I'm done. I can change my success criteria to allow a fewer percentage of duplicates or number of duplicates so as to not trigger the or alarm the test case by changing the success criteria. And of course, I can also add a where condition or other conditions to make sure that this test case only runs for specific records. But I'm already done. This particular rule can be parameterized easily using global and local parameters, and this rule set can be exported and imported as well. The wizard that we saw earlier for data compare, the same can be applied for these set of rules as well. And here I've already created a few set of rules, so we'll quickly go through those. First one is of course a basic null check. Primary key is customer key, and we do want to ensure that that this particular key is not null. And here you will notice that we are using the attribute rule. The attribute rule is one of our most powerful rule templates because it takes into account the data type of the column you're working with. So in this case, email address is a string and correspondingly changes the operators in accordance. So here we see because the data type here is string, contains is number, is not a number, regular expression, pattern expressions, and other such formats come into the picture. And again, this is only because this corresponding data type is a string. And I've used this to ensure that email address contains adventureworks.com. On the other side of the spectrum, we have birth date, which is of course a date column. And as you see, the operators here are is before, is after, and is between, and so on. And so I have basically defined two sets of business rule requirements as basic rule templates that can be easily exported through other systems as well. Finally, if I'm working with something that's a bit more complex that I do not want to work across, I can of course define a SQL query or expression rule. This is very easy if you want to import your existing rules as well. But going back to attribute rule for a second, if I want to define something specific and niche and I want to reuse it, this set of operators here, these can be user defined as well. So you can just define the exact conditions you would like to apply. A developer can go in and define them, and the end user only has to choose the corresponding operator right there. To round out, we do have a few more test cases that we couldn't cover in this particular demo. This is with regards to domain checks, which basically ensures that the data in the column is within the list of expected values, and of course metric value checks. This is where you want to validate your aggregates. Easy example here would be if you want to make sure that the sales figures from two distinct data sets. Imagine you're a manager and you get your weekly sales figures from your team in an Excel, and you get the same from your CRM tool. You would like to ensure that the final aggregate of the total number of sales or total revenue per week is within a certain bound so that it's not too off from what you're seeing within your system. So in this case, you would run a metric compare across the two tables. Other examples would be ensuring that the mean or total or max values do not exceed or are below certain expected ranges, and that's single metric value. Of course, here I've applied this to a transformation, but as you might notice, you can apply this to raw files as well, and that is something that we can cover in data quality monitoring. Of course, before that, we want to have a quick showcase and shout outs to other use cases as well. Where as you see, we have a plethora of use cases, but I want to quickly jump and showcase metadata compare. It's very similar to what we saw when we were creating our migration validation wizard. Here, you're basically prompted to define the different sources of your system, and then objects are dragged and dropped within systems. This is a curated example, but of course I can drag and drop objects in this as well. And the results in this case, instead of going to the actual data, actually tries to match the metadata. So here we see the columns which are present in one, not the other, data type mismatches, and even something as simple as a column length mismatch, which is very crucial for columns such as address lines and demographics. So in this particular fashion, we also perform metadata comparison. Next, what we would like to get into is actually showcasing observability and how exactly it works. So let me just ensure we are Next, we would like to showcase data observability and how exactly it works. So here I've taken a raw file and I want to ensure that I profile this file and I catch anomalies within this file as well. So here it's a CSV file, but once again, the application is pretty agnostic to the data set to the sources of the data set. So this could be a JDBC connection, it could be a report, it could be an API connection as well. Here we've just made sure it's a basic file, and this particular file is loaded after applying a transformation every week or every day. And now, how do we do profiling? Well, the profile node is pretty straightforward for the end user to use because it allows the user to define multiple aggregates across multiple columns. Each of this aggregate count and pattern and frequency analysis is done on every run. So at certain points, if say there's a volume drop within the data, or you've seen the distinct counts have increased, or the distribution has altered, or the patterns that you see within the data sets have changed, the application can catch that. Here in the results, as you can see, we have found a few anomalies within the system. And if I can just go in deeper into yearly income for now, I'll see a much more detailed look using mean. And here I see that yes, while the mean was trying to stabilize itself over the past few runs, it has suddenly had a spike. This implies that something is off within my data set. Mean is just an easiest example to pick up. The other easy good examples could be with regards to volume, with null counts, distinct counts, and other aspects as well. The other things, of course, are with regards to the patterns. This is crucial when you're working with date patterns, or if you're working with licenses or other expected pattern sets, where the things such as primary keys, license plates, or other government IDs that you might expect a set pattern in. But if you see something out of the application or out of the batch or out of trend, the application can directly catch that. And finally, we do have the frequency analysis to match distribution count. So here, if a particular distribution has been altered quite drastically, the application can catch that as well. And now to give the end user a better understanding of how we can work with data observability, we'll actually quickly shift into data quality monitor. Here you'll see that we can actually validate the data sets before they even enter your system, but the application can be applied on any layer, be it ingestion layer or pre-ingestion layer as well. So here we see the data quality score make a return, but of course this is built based on an overall score of each and every record aggregated up to a view level and then a model level and an overall level. Of course, here if I can zoom in, I can actually find a specific data set we want to work with. Let's assume it's customer data model. And here we see that the data quality trend noted for this particular model across multiple tables. And of course, I can zoom into a specific table and find out the exact culprit which is causing the drop in data quality. We see the same set of rules being expanded as we saw earlier. Here we also have one of my favorites, which is foreign key rule, which basically validates referential integrity, basically making sure there are no orphan records within your system before you even pull them within your corresponding system. As we saw with data compare, all the records which do not match the specific system can be isolated for either for reconciliation, for reporting, or for other use cases. The other pillar of data quality monitoring is, of course, anomaly detection. And here data observability makes a return, but in a much better way. So here, if I get into COVID data analysis, sorry, apologies for that. So here, if I get into COVID data analysis, I can actually see if there are cases where predictions have or statistics have, or particularly there have been anomalies have been found within the system. So here, if I scroll back, you'll see that within a particular data set, it was normalized, a particular set of values were normalized, and here machine learning code was actually deployed to understand how the data changes with regards to seasonalities and other variables. So here we see that there were a few variables which were out of bounds, which were unexpectedly high or low, and these were caught within the system. The same thing can be applied on your specific use cases as well. Here the distinguishing factor is defined as the country and measure name, but you can define your very own categories as well using the product. Finally, I'd like to quickly illustrate the reports that we were working with earlier. So here we have a proper run summary. This is at a test case level, and each and every test case has a corresponding report associated with it as well. I can download this report within my system, send it through existing communication channels. But for now, I'm just going to go to the report and illustrate how this works. This reporting system has snapshot capabilities, checkpoint capabilities, and of course everything else within. You can also see exactly what are the rules for that specific system that work with it, and see which exact records fail at that particular point with the download. And you can of course download or use this particular system to reconcile those bad records. And if you do not like this format of reporting, you can either customize this report using adding your own custom widgets, or you can create your own reports from scratch for your entire pipeline itself using the widgets that we saw earlier. As I said, this integrates easily with your existing CI/CD tools and test plans and other aspects. So you can send this report out as mails, or send this particular link out as a mail as well, or as a Jira ticket, or to your Slack or team communication channels. Once again, this is the tip of the iceberg, and what I'd like to end with is plugins. As we see in plugins, we have a good amount of code that the end user can deploy within a single repository, so that the end non-tech savvy users, for the people who want to just work with parameters, they only see the parameters, and you can basically define your own specific set of features without waiting for a product release for this. As you see, the plugins are quite different. We have things such as enrichment of data, anomaly detection, triggering Jira jobs, triggering DBT jobs, reading Excel files, and saving iteration data as well. anything that you want to work with specifically, you can actually create the code for that, and the end user only sees the parameters as we saw at the very start of the demo. There's a lot more to the product, but for the sake of time, we will pause now. Let me know in case of further questions. We're more than happy to answer those. Feel free to connect with us directly for that. Thank you.